Hello everyone. It's a very good day. We are going to learn electromagnetic waves and dual nature of radiation. Based on this, we are going to have these subtopics: displacement current, Maxwell's equations, electromagnetic waves, electromagnetic spectrum. These three subtopics comes under EM waves, electromagnetic waves. Dual nature of matter and radiation we'll discuss as a separate one. Ampere circuital law is line integral of B dot dl for a closed path is equal to mu naught times of current I. This is definitely true in which a current is flowing, but in certain cases where there is no direct current, only variation of magnetic field or electric field will be there. That also resembles some current. See, Maxwell modified this equation into this way: line integral over a closed path B dot dl is equal to mu naught times of IC plus ID, circuit current plus displacement current, where displacement current is given by first circuit current IC equal to dq by dt, and this is displacement current epsilon naught d phi by dt. Here d phi by dt is rate of change of electric flux, or epsilon naught A dE by dt, where A is cross sectional area. Displacement current in case of a capacitor is epsilon naught A dE by dt, or epsilon naught A by d into dV by dt, or C dV by dt. Using this we have many sums. These are all the shortcuts or tricks to solve bigger problems. dV by dt is the time rate of change of potential difference across the plates. Magnetic field between the plates at different points with respect to the axis of the plates. Here is the magnetic field. Tangential direction, the representations are, and at a distance r from the axis, B is equal to mu naught by 4 pi ID into r square by r square. Sorry, r by r square. On the axis, B is equal to 0. On the axis B equal to 0, and at a distance r from the axis, mu naught I by 2 pi r. Maxwell's equations. If here, before going to Maxwell's equations, I want to tell you here what I wanted to say in this, that is, suppose here is a conductor with cross sectional area, conductor with radius r, suppose capital R, and suppose you want magnetic field along the conductor, along the axis. Here definitely no doubt 0, but if you want here at this place, which is at a distance small r, then magnetic field is given by this formula: mu naught by 2 pi I into r by r square. That means inside the conductor you can use this formula. Outside the conductor, as usual, mu naught I by 2 pi r only will come. So this is inside the conductor. For inside the conductor you can use this formula. Okay, next, Maxwell's equations. Very first equation is Gauss law. Yes, E dot dA is nothing but total flux emerged out. Total flux emerged out from a closed surface is equal to q by epsilon naught times 1 by epsilon naught times of q enclosed in it, which is nothing but Gauss line electrostatic. That is Maxwell's first equation. And integral of E dot dA, integral B dot dA, Gauss law of magnetism. You know, I told total flux emerged out from a closed Gaussian surface in view of magnetism is 0. Total flux from a closed surface is 0. Reason: monopole do not exist. Always poles exist as dipolar. Poles always exist as a dipolar. So that's why total flux will be 0. Next, E dot dl over a closed path is equal to minus d phi by dt of magnetic field. This is Faraday's law. E dot dl is nothing but potential difference. Potential difference equal to minus d phi by dt, which is nothing but Faraday's Lenz law. Next, integral B dot dl over a closed path is mu naught I naught into mu naught epsilon naught d phi by dt of electric field. This is Ampere Maxwell's law, and the second part is only excluding mu naught, epsilon naught d phi by dt, whatever is there, that is displacement current. And vector form of electric magnetic field forces on a moving charged particle, which is characterized by Lorentz force, that is F bar is equal to Q into E bar plus V bar cross B bar. Vector story only this is. Next, EM waves are non-mechanical, transverse, self-sustained waves which consists of electric magnetic fields oscillating in mutually perpendicular planes. Electric and magnetic fields are mathematically represented by the given equations. These are all electric field equation, magnetic field equation. See here, omega t minus kx, it indicates that it is propagating along positive x-axis. It is propagating along positive x-axis, and Ey represents electric field along y-axis, Bz represents magnetic field along z-axis. And direction of propagation is always given by E bar cross B bar, only for the direction purpose. Actually, E bar cross B bar is proportional to Poynting vector, so it will give you only the direction, right? Not the magnitude of velocity or something else. Speed in vacuum for an electromagnetic wave is E by B, E naught by B naught. This is speed in vacuum. E by B is, you can E naught by B naught peak values, E and B are instantaneous values, and C is equal to 1 by square root of mu naught epsilon naught. Mu naught is permeability of free space, epsilon naught is permittivity of free space. If you substitute those values, you will get 3 into 10 power 8 meters per second only. Speed in any medium is given by 1 by square root of mu epsilon. Here many people get confused with this formula, and refractive index is equal to square root of mu r epsilon r. Relative permeability, relative permittivity. So these three formulae try to recollect as much as by taking care. These three are little confusing. This is refractive index. This is refractive index mu. That's why I didn't use the symbol. If I use symbol mu, then you may feel that is also one type of this one, permeability. Poynting vector S bar is equal to E bar cross H bar or E bar cross B bar by mu naught, represents the direction of energy flow per unit area per second along the direction of the wave propagation. Poynting vector, that is, this is nothing but intensity of the wave flow is given by Poynting vector. For an EM wave, these points are very important. Average electrical energy density. Average electrical energy density means average energy per unit volume is 1/4 of epsilon naught E naught square. Average magnetic energy density. Average magnetic energy density is 1/4 of B naught square by mu naught. And total average energy density, sum of these two are double of any one, because both average densities, see, quantity of energy in electric field propagation, quantity of energy in magnetic field propagation will be equal per unit volume, but their peak values of electric field intensity, magnetic field intensity are different, but quantity of energies are same. So this is half epsilon naught E naught square or B naught square by 2 mu naught. This is total energy transmitted per unit volume. That's why total average energy density it is. Next, intensity of radiation. Intensity is nothing but energy per unit area in unit time. Intensity is nothing but energy per unit area in unit time, nothing but power by area. So watt per meter square is the unit for it. So half epsilon naught E naught square into C. This is magnitude of Poynting vector. ERMS BRMS by mu naught. Half E naught B naught, because peak values by root 2, peak value by root 2 will come, so that will be 2. Intensity of electromagnetic radiation from an isotropic point source at a distance r is I is equal to P by 4 pi r square. If P is constant, I is proportional to 1 by r square. When an electromagnetic wave strikes the surface and it is absorbed totally, then the total momentum delivered to the surface is P is equal to U by C. If it is absorbed, momentum delivered is U by C. If it is reflected, then momentum delivered will be 2u by c. Where is that? Yeah. When the radiation incident on the surface is entirely reflected back, then its momentum transferred to that body is P is equal to 2u by c if it is a reflecting surface. When radiation is incident on the surface, radiation pressure is P is equal to I by c. This is momentum transfer. Don't get confused with the letter P. This is momentum transfer. This is radiation pressure. Radiation pressure is I by c or 2I by c. If it is reflected or absorbed. If it is absorbed just one time, reflected 2 times. All these formulae you need to know, you need to practice. It's a small chapter, very small chapter. That's just 4-5 slides chapter. If you practice all these formulae vigorously, excellently, then happily one bit you can bag. Dual nature of radiation and matter. In this lesson, we have the structure or the subtopics: electron emission, photoelectric effect, experimental study of photoelectric effect and the wave theory, Einstein's equation of photoelectric effect, energy quantum of radiation, practical nature of the light, the photon and its characteristics, wave nature of matter. So these things we are going to discuss in this. Work function. The minimum energy required to remove a free electron, from the metal is called work function. The minimum energy required to remove a free electron from the metal is called work function. Work function is given by h nu naught. This is not V nu, h nu naught or hc by lambda naught, where nu naught is called threshold frequency and lambda naught is called threshold wavelength. And lambda naught, when in angstroms, then work function can be written as 12,400, but actually it is 12,375 only. 12,375 only. Okay, we are taking 12,400. But whenever the number is multiples of 375, then you can first try to choose that only. Lambda naught is equal to, lambda naught should be in angstroms, and 12,400 you can use if lambda is in angstroms, then work function will come in electron volt. Not only work function, any photon energy you can get in electron volt if you substitute lambda value in angstrom. 1 angstrom is 10 power minus 10 meters and 1 electron volt is equal to 1.6 into 10 power minus 19 joule. 1 million electron volt is 1.6 into 10 power minus 13 joule. If n photons are emitted in the time t by a monochromatic source of power p, then n photons are emitted, then nh nu by t is the power, or nhc by lambda into t. Intensity of radiation I is equal to P by A or P by 4 pi r square. Intensity of radiation I is equal to P by A or P by 4 pi r square for point structure, point source. For cylinder I is equal to P by 2 pi RH, and Einstein's photoelectric equation is given by energy of the photon incidence on the metal surface equal to work function plus kinetic energy of the maximum electrons possible energy. So E is equal to h nu, that is equal to hc by lambda. You can replace W naught is h nu naught, hc by lambda naught. Kinetic energy you can replace with half mv square or p square by 2m. Next, kinetic energy can also be written as using stopping potential EV naught, so that h of v nu minus nu naught, hc of 1 by lambda minus 1 by lambda naught. Stopping potential V naught is equal to h by E into nu minus nu naught, that is equal to hc by E into 1 by lambda minus 1 by lambda naught. Maximum velocity of emitted electron V equal to root over 2h by m, nu minus nu naught. And laws of photoelectric effect. Photoelectric effect is directly proportional to the intensity of incident radiation. Photoelectric current, not effect. Current is directly proportional to intensity of incident radiation, provided the frequency is greater than threshold. For a given frequency of incident radiation, stopping potential V naught is independent of photocurrent. And Ke maximum and stopping potential are proportional actually. Photoelectrons vary linearly with frequency of incident radiation. When frequency of incident radiation is less than the threshold frequency, photoelectric effect will not occur. Very clearly I can tell you two things, Chinna. That is, stopping potential, kinetic energy directly proportional to frequency, and current I is proportional to intensity. These two are different things. Don't merge them. If you increase intensity, current only will be increased, but not stopping potential. If you increase frequency, kinetic energy will be increased, but not current. So current is different, stopping potential is different. They are independent things. Graphs. Intensity, photocurrent, directly proportional. And stopping potential, as intensity increases, photocurrent increases. So this is stopping potential thing. And in this case, you see, what is your inference in this? Photocurrent is same. That means light intensities are same for the three curves. And here three curves are there. Three are having different stopping potentials. As they are having different stopping potential, their frequencies are different. So one is having high frequency causes high stopping potential. Okay, but their intensities are same. That's why currents are same. So like that we can assess the things. Stopping potential, frequency. Slope m is equal to v naught by nu is equal to h by e. X-intercept gives threshold frequency on the graph. The graph, where is that graph? No graph. I'll draw here and I'll show you. This is frequency and this is stopping potential. Then graph will come like this. This point will give you threshold frequency and this one will give you minus h by e into nu naught. This is y-intercept. This one only, this one. That is work function by E, charge of electron. Work function by charge of electron is y-intercept. So this graph is also related to Einstein's photoelectric equation. Dual nature of matter, de Broglie hypothesis. De Broglie hypothesis is every moving particle is associated with a wavelength which is called de Broglie's wavelength, lambda equal to h by p. If the particle moves faster with more momentum, then whose wavelength will be smaller and high energetic wave will be associated with it. H by mv. H by square root of 2mk. H by square root of 2mev. These are all the formulae to solve problems. For electron, lambda is equal to 12.27 by root v angstroms. But in physics, you shouldn't write like this. 1.22 into root v. This is accelerating potential, nanometers you can write, because one digit after point writing is custom. So it should be like this. And for proton, 0.286 by root v angstroms, and for all deuteron 0.202 by root v, and for alpha 0.101 by root v. Easily memorizable. At least memorize for electron 1.22 by root v. When a material particles like neutrons are in thermal equilibrium at absolute temperature T, then lambda is equal to h by square root of 3m kBT, where k is here Boltzmann's constant, 1.38 into 10 power 23. Next, for neutron, lambda equal to 0.286 by root over ek. Lambda is proportional to 1 by root t, lambda 1 by lambda 2 equal to root t2 by t1. For a gas molecule, lambda equal to h by p, that is equal to h by v max into mv max, where mv max is square root of 3 kt by m. These are all derived formulae. Basic one is single. Next, Heisenberg's uncertainty principle. What is that? It is not possible to measure both position and momentum of the particle at the same time exactly. Delta x into delta p is equal to h cross, which is nothing but h by 2 pi. Davison and Germer experiment gives the evidence to what you call de Broglie's hypothesis. The first experimental evidence of matter waves does. So de Broglie wavelength can also be determined using formula lambda equal to 1.22 by root v nanometers, and by accelerating them through 54 volts, then you are going to have 1.67. And accelerate yourself, keep on working. Let us discuss numerical problems on these chapters in a specific session. Bye.